And it says recording, so we're good.
Cool. All right.
Okay.
Well, welcome everybody. This is the Mission to Mars panel, and today our presenter is Bridget Landry. And I just wanted to let everybody know that Bridget is sharing her screen, so currently nobody is on video. But please be sure and keep yourselves muted while the presentation's going on. And Bridget will let you know when you can ask questions. So I'm just going to turn this over to Bridget. So take it away, Bridget.
Okay. Thanks. Thanks for having me. I have been working in spacecraft operations for 30 years plus.
Yes.
And I've spent a lot of that time on Mars missions, and quite frankly, they're my favorite, but you know, you're not supposed to have a favorite child, but I do. So today I'm going to talk to you about all the Mars rovers. Okay, so this is just to give you a feel for how many landings we've had. We started out with Viking 1 and 2, and then came Pathfinder, and then the MER rovers, Opportunity and Curiosity, Opportunity and Spirit. Then Curiosity landed, and Insight. Phoenix was in there. Phoenix was before Insight because it's the similar chassis. And then Perseverance, as you all know, landed this year. This is just to give you a feel for the difference in size in the various rovers. This is Sojourner. This is Spirit and Opportunity. This is MSL, Curiosity, but Perseverance has the same chassis, has all different instruments, but it is similar in size. So you can see it's about the size of a Mini Cooper, whereas this is about the size of a small microwave, VCR. I worked on Pathfinder, and it was a fabulous mission. It was the first Mars rover, first autonomously operating rover on another planet. It was 6-wheel drive, 4-wheel steer. We had hazard avoidance. This is back in the 90s. There wasn't nearly as good AI, but we had what we could. We had cameras in front and back, a color camera, and alpha proton X-ray spectrometer that helped us to analyze rocks. This is seminal. This is the first time we've been able to take a picture of a lander during its prime mission. So this is a shot of the Pathfinder base station from the rover, and that's just really cool. One of the things we wanted to see was what the wheels did to the terrain. That gives us a feel for just how, if there's a crust or if it's loose sand, if there's a bedrock layer underneath the sand. It gives us a lot of information about the physical properties of the soil that we're traveling over. This is Yogi. That was the first rock we went to. Well, not the first rock. It was the very large rock that was very close to where we landed. And we were able to get around. And this is a side of the rock that, it's not the back of it, but it's like 90 degrees from the images that the lander could take. So we were able to get, see around the corner, which is one of the valuable aspects of having a rover. This was the various rocks that we named them. I have to tell you that we started naming them after cartoons because, well, it was very late and we were working Mars time, and so we got a little silly. And what they ended up doing was they took one of the first panoramas and put it up on the wall And when you had a few minutes, you'd go in and put a sticky note with the suggested name on a rock. So, so yeah. We did get a lot of flack about naming them after cartoon characters. And I just really never understood that. It's like, really, you're going to change the science you get out of it because it has a silly name?
I was going to say, Bridget, it was kind of hard to see what some of those names are. Can you just tell us what some of them were?
Oh, let's back up and take a look. So we have Pooh Bear, Squash, Mermaid Dune Form, Photometry Flats, Cradle, The Dice, Souffle, Barnacle Bill, Bam Bam, Stimpy, Mo, Half Dome, Scooby-Doo. And I have to tell you, we purposely did not use Disney names because
yeah,
we didn't want to go there. And one day I came in for work and the Cartoon Network had shirts printed for us that had Yogi and Scooby-Doo with the Rover, waving at the Rover. So that's one of my favorite mission shirts.
That's awesome. Thanks.
So, and this is one of the first selfies. It was an early attempt at a selfie. As you can see, there's a real empty spot here underneath where the camera is, but we've refined the art of the selfie quite extensively since then. But this just gives you a feel for where exactly the Sojourner went over the course of the mission. As it turns out, the rover was only slated to survive for 7 sols, and the lander was slated to survive for 30 sols. We lost contact with the lander on sol 87, so we almost tripled our original duration, but the rover was still going. It's like the Energizer Bunny. It just, as far as we know, it still was functioning beyond when the lander lost the ability to communicate. So yeah, I think you can say over-engineering. This is the landing system that was used both for Pathfinder and for Spirit and Opportunity. It was developed for Pathfinder, and it was a challenge. We had to go back and redesign the airbags several different times. But we finally got something that worked, and the fabric of the airbags is laced with Kevlar, because what you're bouncing on is basically volcanic rock, which is very sharp. So we had to find a way to keep them from popping. And there was, of course, a pool on how many times we would bounce, and we did in fact bounce 17 times. But it worked very well for Pathfinder, and so they decided to go ahead and use the same landing system for Spirit and Opportunity, although the rover, there was no lander per se, base station for Spirit and Opportunity. Everything was on the rover for those 2 missions. Again, 6-wheel drive, 4-wheel steer, many more cameras. We had a thermal camera and a microscopic imager, which is the equivalent of a geologist's hand lens. Again, an APXS for elemental analysis. And we also had a spectrometer and a rock abrasion tool, which is basically a drill. Sorry about that. Moving on. This also had a robotic arm. On Pathfinder, they just had a deployment mechanism, which was kind of like a lever arm to put the APXS down on a target. Spirit and Opportunity had an actual multi-jointed arm that allowed them a lot more freedom for picking targets and analyzing them. This is one instance where we used the wheels as a sampling mechanism. We dug into the soil to determine, to see what was underneath. And this white material suggests that there was water underneath at some point, in the distant past, but we were unable to stay here and take a look at it. We were aiming for a specific target. We needed to get to a specific slope so that we could survive the Martian winter. We needed to be slanted towards the sun to improve our solar panel response. So we weren't able to stop and analyze this more carefully. Okay. This is Endeavour Crater, which is where Opportunity ended up near the end of its mission. 44 kilometers. That's quite the distance to have traveled very, very slowly. It doesn't move fast, but it's persistent. Marathon Valley is where we ended up getting where we were when we hit the 26-mile mark, hence the name. And that was on the edge of Endeavour Crater, as you can see in that image. That Cape Tribulation was called that because we got stuck, and it took a while to get out. So some of the names are very apropos to what was going on during the time of the visit. This are some of the last images from Spirit. Spirit died significantly before Opportunity. It first lost its ability to move. The wheels locked up and we were unable to move. But the camera and the arm were still functional, so we were able to use it as a stationary platform for some period of time before it finally passed. Opportunity ended up started out with the four-wheel steer, ended up with only two wheels steering. We had one wheel that we had to drag along like we were Igor. We lost the thermal camera over the course of the mission and lost the spectrometer, but the color and black and white cameras, the navigation cameras, the APXS, the microscopic imager, and the abrasion tool all kept going. This is from that time, as I said, that where the wheel got stuck and we ended up dragging it. So that's known as sprained ankle. And so this was one of the panoramas that we took from that spot. One of the reasons that we wanted to get to the Endeavour crater is because it gave us a look into the past of Mars. Because it had been excavated, you could examine layers from previous eras, as well as the top layers that surrounded it. That's just gives you a feel for what it looked like close up. This is actually an image from High Rise, which is one of the cameras on MRO, which is orbiting Mars, and it's of Perseverance Valley, and they had looked at this from orbit and wanted to get a closer look with the rover, because there was debate about how these layers formed, whether the contours were formed by wind or ice or water. And so by being there rather than just seeing it from orbit, we were able to get more information. The determination that we were able to do from being there was that the only way this could have been formed was by some moving liquid. The slope is too shallow to be formed by anything else. So this gives you a feel for how we use data sets between the landers and the orbiters to answer questions that neither mission could answer on its own. This is a microscopic imager, and it's etched and eroded by wind-blown sand. And as you can see, this is a larger image, and this is a close-up with the microscopic imager of this portion. This was a gully that we were able, it's the first time we were able to explore a gully, and checking the textures and compositions all the way along it to see how they changed along the path. The shape of the rocks gives us a feel for how it formed, but it was harder to understand than we anticipated. The problem is we're getting multiple sources of resurfacing, and it's hard to untangle which ones would be water and which ones would be wind-blown, and which ones might be the result of water freezing and breaking things off. So work in progress. Just a cool picture of Perseverance Valley. You can see we chose a path very carefully. We wanted to be close to where these rocks were on the left of this image, but we didn't want to get too far in there because it's more difficult to navigate with those rocks the way they are, this bedrock slatish kind of terrain is much better for traction and travel. These are the last images from Opportunity. And you've probably seen something that said that the last message was, I'm getting cold and it's getting dark. It's a personification, but that is essentially what was being said, that the dust storm was coating the solar panels and also blotting out the sun, basically. So that is how we finally lost it. So it was unable to keep itself warm and to keep the electronics functioning. And these are pictures of the sun, and they're stretched very hard because there was so much dust in the air that you really couldn't see the sun. It had to be processed extensively just to get that much. So it was kind of sad because, again, the Spirit and Opportunity were only expected to last for a year, an Earth year, and Opportunity ended up lasting 15 years. So once again, just a tad over-engineered. So Mars Science Laboratory. This is the big brother. Curiosity is her name. She was big enough that they weren't able to use the airbag system. They had to develop a whole new landing system. The reason there's a concern about the landing with rockets of this sort is because you're basically contaminating your site with all of that rocket exhaust. And so to solve that, they did this technique of rappelling it down from the descent stage. And it also prevented the rocket exhaust from kicking up as much dust onto the rover, which was not as big an issue for Curiosity because it's not solar powered. It has RTGs to power it, but still, you don't want dust flying around your sensitive machinery. So they cut the cable and landed the rover, and then the descent stage veered off and crashed elsewhere. I'm sorry, I've got this in the wrong order. This is Endeavour Crater. That's so. This is a much higher functioning rover. Lots more instruments, lots more cameras, frickin' laser beams to vaporize rocks, parts of rocks, and then analyze the plasma that's released. A drill, a scoop, a brush, sieves to sort things. We have a online onboard chemistry lab, both a mineralogical one and a chemistry and isotope analysis. We have an instrument that looks for subsurface hydrogen, and the importance of that is it lets you find water or ice underground. We have weather stations, lots and lots of, and a much more sophisticated arm with a rotating head and several different instruments as well as the drill on it. So Gale Crater and Mount Sharp are where Curiosity landed. This is actually an image from Mars Reconnaissance Orbiter, which I was working on at the time, of the parachute stage of the landing. So again, very unusual to be able to have one spacecraft image another. And so, although Mars is the place to do it because it's lousy with rovers and landers and orbiters. There's just a whole lot of stuff going on at Mars. And this is really cool. Again, Mars Reconnaissance Orbiter was able to image where Curiosity landed and the first tracks she made as she was driving away, which I just think that's really cool that we can see it from orbit. This is a path that we started to take. We're trying to climb Mount Sharp. The reason this is interesting is because there are 3 distinct layers that we can see on the edge of Mount Sharp. The lower ones contain minerals that form only in the presence of water. The middle layer have minerals that suggest that some water was present at some time, but they are not always required. And then the upper unit, it does not have hydrated minerals as much, and may either represent the original bedrock or material that was deposited there during the impact. So it gives you a feel, it gives you a measure of the whole history of the region just by going up the slope. And so that's one of the reasons why this site was chosen. What am I doing on time? This is just another showing of that, the lower water-rich minerals, the higher levels that have some water minerals, and then the sulfate units up at the top where they do not require the presence of water to form those minerals. This was scouting out how we were going to climb this slope. Every day we take pictures and put it into a 3D mesh for planning out how we're going to drive the rover. Just really cool pictures. And this is before we got there, but this is where, oh no, this is where we landed, and then our path along to where we are here on Vera Rubin Ridge. Just a better showing of all the different layering and various materials that we were able to sample by visiting this area. Dust devils. Dust devils are your friend. This is an image from MRO of a dust devil imaged from orbit. The white is the actual dust devil, and the black is the shadow of the dust devil. We actually had several instances with the MER rovers where we were expecting to lose the mission, and then a dust devil came by and cleaned off the solar panels so that we had more power. And it's like, cool, let's keep going. We could sure use a dust devil on InSight, I have to tell you. Okay. Oh. Why is that not going? Huh. Okay. Did it before.
Bridget, the rim no, messing with you too?
Yeah. I'm not sure what happened there. I had a video that I've used before, so I'm not quite sure what's going on. This is a close-up of one of those layered sections from the hand lens. And just, you can see that the layers go down to very small scales. Another hand lens, this is about 25 centimeters from the surface. Isn't there a scale? Guess not. We're looking at crystals in these rocks. So this is the larger image, and then this is the close-up of that. Yeah, there we go. This is 2 centimeters. So this is very fine dust here. This is our drill. It's it has these stabilizers to press against the rock so that we know exactly where the drill is, and so that we can keep it in place so it just doesn't hop all over. And this is how one of the methods that we use to get samples into our testing mechanisms. It goes up, it's like an Archimedes ladder where the material goes up the screw threads and into the chamber and then out into the sampler. And we've actually been pooping. We do the analysis and then dump it out on the surface. Okay, and this is showing it in process. You can see the stabilizers there, and then the drill is getting ready to deploy. We have had some trouble with the drill, and they were able to make it work, using it in a different way than expected. And just as a point of pride, when we went in lockdown last year, we only missed 1 day of activities on the rover, and the day we came back, we actually did drilling, which is very complicated. So we definitely nailed it in the transition to working from home, despite the cat's best efforts to command the spacecraft. This is just a close-up of the drill actually on Mars, and you can see that it's got dust on it. And this is part of our testing for the issue that we were having with the drill. So, and then, as I said, we got much better at taking selfies. You know, on to Mars 2020, Perseverance. As I said, 2020 is the same size as Curiosity, but it has a whole different suite of instruments, including 26 cameras. So, and as you can see, we have some international partners on the mission as well. This is the descent stage in the high bay when it was being assembled. This is something that was kept a secret until it actually deployed. This is the parachute that was used, and it says in code, "Dare mighty things," which is the kind of slogan of the Mars missions. And it has around the outside, it's the latitude and longitude of JPL, because we're nerds that way. This is from Perseverance's landing. Thought this was Eric.
We are starting to straighten up and slide right here. We'll jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Taking the pitch, shoot deploy.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
These are actual images. This is not artist renditions.
Net filter converged. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface. Perseverance is continuing to descend on the parachute. We are commenting on the initialization of terrain relative navigation and subsequently the timing of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LDS valid.
There's confirmation that the lander vision system has produced a valid solution as part of terrain relative navigation.
Flagging. TBA nominal.
We have timing of the landing engines.
This is the first time we've had
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. There's confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in 50 Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky plane, let's conduct the sky plane maneuver. Sky plane maneuver has started. About 20 meters off the surface.
again, these are all images, not simulations.
Getting signals from the camera. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
You'll notice that they were all masked up because they actually had to finish building the spacecraft, ship it to the Cape, launch it, and guide it all the way to Mars during the pandemic. While we were working, we did as much as we could from home, but a lot of those people had to go in. And so, yeah.
We're starting to straighten up and
These are just some of the interesting bits. We have a stick family on the rover, which is kind of amusing. This is an homage to the healthcare workers that were on the front lines during the pandemic. And so they honored them by putting this plaque on the rover. Remember what this is. Sorry, I've forgotten what these two are. I believe this is the I'm sorry, I've forgotten what those two are. But some, just for interesting facts, Sherlock, one of the instruments, has a coin with 221B Baker Street on it as part of its calibration targets. Spirit and Opportunity actually had bits of 9/11 wreckage on board them, and Curiosity has a 1909 penny on board. So, okay. These are some of the, one of the things that Curiosity, or that 20 Perseverance has, is a microphone, and we have not had that before. So this is first time we're hearing sound from Mars. That's the actual sound that it measured. Some of that is the rover sound, and some of it is wind. This is just the wind from a couple of days later. And this one is the laser beam vaporizing pieces of rock. It's formed in a grid. I just think that's really awesome. Oops. Okay, I want to show you a couple of things from YouTube, because that's where you get your best science from. Okay. One of the interesting So this is really totally cool. This is the helicopter, which is the first time we've had anything like this. And here it comes. I saw a meme with a picture of Ingenuity and a drawing from Leonardo da Vinci. And it's very, very similar. So it only took us a couple hundred years to make it work. And I got one more, and this is a little shorter, so it shouldn't be too bad. This is anyway, that is my presentation. If you have some questions, I'd be happy to answer them at this point.
Hi, hang on a second while we let everybody be able to unmute themselves when they have a question. So everybody, please only unmute yourself if you've got a question for Bridget, but you should all be able to do that now. Anybody have a question?
I was asking earlier about what a sol was, and I got the answer that it's a Martian day, but it said sol 12 and then a comma and what looked like a year or something. How do they determine those dates or whatever they are? On some of those?
Each mission has counts the number of sols they've been on the surface or at on the surface of Mars. A sol is a Martian day, which is 40 minutes longer than an Earth day, which is why we use a different term so that we know which one we're referring to. And so some missions, I mean, the MER rovers were up into the 5,000 and 6,000 sols. InSight, which is the mission I'm currently working on, is about 800 sols into its mission.
Okay, so it restarts that count for each mission.
Correct.
Thank you.
What is the most exciting thing you see happening next at Mars?
Ooh. The next plan is one of the things that 2020 has is it has a caching system. So it's going to take samples of various rocks, but it has no way to return them to Earth currently. So it's going to cache them together. So the next exciting thing would be the mission that ends up going to Mars to pick up those samples and return them.
Very cool.
Bridget, we did have a couple of questions through the chat. Let me see if I can find one.
Gotta run to the store real quick.
All right. One of the mystery plaques via the NASA website Lazarus graphic depicted Earth and Mars joined by the star that gives light to both. That was the one you didn't know. I couldn't remember.
Thank you. That's, I was gonna guess that that's what it was, but
That was from Charmaine.
thank you, Charmaine.
Sarah wanted to know if you ever came across any mineral samples that you were not expecting.
Any what samples?
Mineral samples that you were not expecting.
Less these days because we get a lot of information about minerals from the orbiters that have done quite a bit of mapping of the surface, and we tend to only take our landers to places that we've investigated carefully from orbit. But some of the hydrated minerals that we've seen, hematites and clays and things, were a surprise when we first found them. Those were some of our indications that there was standing water at some point in Mars's past. So yes.
Okay, and Ricky is asking if you could, all right, if you could immediately know the answer to any one question about Mars, what would it be?
Was there ever life there? Hands down.
What keeps the scientist up at night?
Well, there's a lot of ways to interpret that. One is, holy moly, did I screw something up? One is, that wasn't what I expected. How could that happen? And what is, where do we go from here?
And Emmanuel wants to know, what do you think is the next step in Mars research?
They're
asking some toughies.
Yeah, that's a tough one. I'm not sure that there's a different next step. I think we're in the middle of a lot of data collecting. We're coordinating orbital data and surface data, and that's going to be taking up a lot of our time for quite some time. It's a big ass planet, even though it's smaller than Earth, and we really haven't investigated on a detailed level that much of it. I mean, we have images of most of the surface, but some of the images are from like 1972, so, from Meritor 4. And some of them are less resolution than others. Some areas we've investigated very carefully, and other areas we just haven't gotten to yet. So I think increasing the amount of area that we've covered at higher resolution imaging and more landers to sample things, or rovers to sample things. I'll be interested to see if we get any information from the Chinese from their new rover.
And Ricky wants to know, if you could impart one thing to the next generation of kids, what would you want them to know or do?
I think I would want them to understand that things that are hard to do are the most satisfying. That why would you want to do a job that was easy? Doing something that's never been done before, or doing something that really challenges your imagination and that you end up failing at times is incredibly satisfying. It can be frustrating, but when you finally make it work, there's no feeling like that in the world. It's just amazing. You're muted.
Oh, Nancy, yeah.
Well, my My critters that share my house are getting noisy.
Were there any other questions?
Still have time. Jump in. If you've got a burning question, you don't have to type it in the chat. You can come right out and ask. We'll let you.
Hush.
So I have one, Bridget. So if somebody is interested in working in the aerospace technologies, what would they need to study and how would they get started?
There are a lot of different paths. Any kind of science, chemistry, biology, math, chemistry, biology, physics, studying math. I would not recommend straight computer programming. You should do your programming in concert with a science or engineering aspect. We have some trouble retaining programmers at JPL because we have to have things very, we're not on the cutting edge in some ways. And so it is not as exciting, and we don't use the latest languages or tools because they've not been vetted yet. So programming is very valuable, scripting is very valuable, but it needs to be in context with science or engineering background as well.
So any use for COBOL programmers? Just asking for a friend. So,
Well, I heard they needed them, a couple of years ago.
Okay, we've got someone else asking, do you think the Chinese will indeed share their info? Or is their politics tainting the science?
I honestly don't know. NASA has always been really good about releasing. They have strict rules about releasing the data as soon as they can. I don't know what the Chinese, what rules they have and what they're going to do. I would hope that they would be as open with their data as we are, but yeah, politics is a reality.
And then another question is, do different countries have parts of Mars claimed?
If you saw The Martian, you know that Mars is international waters. And
well, just because it was in a movie doesn't mean it's real.
Well, that's true, but it's a valid question. There's so
much question, but they did get that right. That is,
Okay.
anything off of Earth is considered international waters.
Cool.
And Emmanuel wants to know if you add any gadget on a rover that is not currently on there, what would you add and why?
Ooh. Boy, that's a tough one, especially with 2020 having just having the microphone and the helicopter. Ooh. Oh yeah, okay. One of the things the Martian got wrong is that the rover didn't have lights because it didn't run at night, and so I probably would would put a light on it somewhere. Just you never know what you're going to find.
Maybe that's when all the Martians actually come out at night when they can't be seen, right?
Yeah, like the vampires.
Right, exactly.
Vampire Martians.
That's it. Maybe someone should write that novel. There we go. Vampire Martians.
Are there other questions?
Yeah, we're reading the chat. So if you guys put anything in the chat, we'll catch it. I'm just trying to think of other questions. So go ahead.
Does Mars have an area in darkness like the moon?
No, because Mars's axis is tilted quite significantly. So there are parts that are in darkness for half of a Mars year, but there's no place that's in darkness. I mean, unless it's a cave or a overhang or something, but there's no portion of the surface that is inherently in darkness the whole time.
Well, I was going to say, but the moon's not in darkness either. There's the backside of the moon that everybody always incorrectly refers to as the dark side of the moon, but it's just we don't see it, but it sees the sun.
Well, we talked about this in the previous panel, that there are apparently places in the north and south pole of the moon that literally never get any sun.
Oh, okay. So there are places, just not an entire side of it like people usually.
Exactly. It's a small portion at the poles.
Gotcha. I missed that from the earlier panel. I was dealing with some technical difficulties.
Yeah, we've had a lot of those.
Yeah, it's virtual things. Deal with them.
Okay, another from Sarah wants to know, perhaps a version of canned dust to clear the solar panels.
Yeah, there's been a lot of speculation about different ways that we could do this. I'm not sure what the difficulty is about having a brush or a blower of some sort. I will tell you that we're doing some interesting things with Insight. We're going to strum the edge of the solar panel to try to pop some of the dust off. So I'll keep you posted on that one.
Yeah, that sounds interesting. So basically using harmonic vibrations to knock the dust off?
Actually, just kind of, we're hoping that just by flipping the edge of it, it'll.
Okay. So what was that? Oh gosh, I forgot what we used to call that. Anyway, yeah, kick it basically.
Yes, percussive maintenance.
Percussive maintenance, thank you. That was the word I couldn't think of. Percussive maintenance to the rescue. Okay.
Okay, Ricky wants to know, in science fiction, we read a lot about terraforming. Is this actually a reality or just fun science fiction?
Well, I wrote a term paper about that years and years ago, back when I was in grad school. And there are ways to do it. It's orders of magnitude harder than we really want it to be. It's like the math works out, but whether we'd ever be able to actually afford it, not only financially, but energy wise, it's hard to say. I mean, it's technically feasible. I don't know how practical it is.
And then Kathleen asked a question. You said the biggest question you would like to know is, has there ever been life on Mars? What would prove that to you?
Oh, there's a lot of different things that you could find. Obviously, a couple of trilobites would be helpful. But there are signatures in isotopic ratios that we have found are unique to life. And so if we found certain minerals enriched in certain isotopes of carbon or nitrogen or oxygen or hydrogen for that matter, that would be strong evidence. Obviously, if we found life, but the question is, how do you even determine life? I mean, if you, I was on a pre-planning of a mission that was going to land on Europa, melt down through 4 kilometers of ice, and release a submarine into the ocean. And I spent several days with some fascinating people discussing how you would determine if you found life. And the easiest is, of course, if it comes up and knocks on your lens. But the techniques ended up being, okay, it was alive, but now it's dead. So, you radiate something, and if something changes, oops, we killed it. It ate my lunch, which is if you put out materials, and if it gets consumed, then there's a strong possibility that there was some life there. But life as we know it, we can find. But what life as we don't know it, that's a challenge. So that's some of the very smartest people I know are working on that question. How do you determine whether there is life and whether there was life? But really the isotopic fractionation or certain materials that are largely made biologically would probably be what I would look for.
Sounds good. Does any last minute questions for anybody? You can say it or you can chat it. Going once. Going twice.
That was
Bridget?
ridiculously interesting. Thank you so much for taking the time to talk to some of us people who just don't have the background, but for couching it in words that we can understand. And I've got kids listening in on the background, and they're just absolutely fascinated. So thank you so much.
Thank you. Thank you for having me. I love doing these kinds of things. I love this work, and to share it with people who are interested is just awesome.
Bridget, thank you. You've enlightened us. You've shown us gorgeous pictures, and we've learned stuff. I know I have. And I really appreciate your time. Save about this time next year, we might ask you for something else. So, think about what you'd like to do.
Okay, fair enough.
And Teri, do you have any final parting words?
I can't think of anything other than to add my thanks and, talk to you later.
Okay.
Okay.
Everybody, our next session will be at 4:30.
No, it's 5 o'clock already.
Oh, it's 5. Okay. So, on mine, I have changed them to Central Time. So.
Oh, 5:30 Eastern, right? No.
Yes, 5:30 Eastern will be a video. Vera is reading the glossary from Ace and Blue. And then at 6:00 p.m. Eastern will be our Hollywood panel, and you will not want to miss that. Thank you all, and have a good day.
All right.
Bye,
Thank you.